I'd go. Okay. Coterminal angles are how far apart? Delilah. Huh? How far apart are coterminal angles? 360 degrees. So if we go 360 degrees more than this, we get 588 degrees, right? Okay, a negative coterminal angle. What's the nearest negative coterminal angle? Or the biggest negative coterminal angle? 100 and negative 132. 27 degrees, what quadrant is it in? 1. Converting to decimal degrees, you take the 40 and divide by 60. There's 60 seconds in a minute, 60 minutes in a degree. So it's 45.666, repeating, divided by 60. And I don't know what that is exactly, rounded to 4 decimal places, but you're going to get 55.75 what? 45.66666 divided by 60, which is 0.75 what? 0.7611. Sounds good to me. All right. So on this one, it's going to be 66 degrees, and then you take 0.455 times 60. You multiply by 60 instead of dividing by 60. Multiply by 60, and you get 27.3 exactly. And then you take 0.3 times 60, and you get 18. Okay, converting to radians. To convert to radians, you multiply by pi over 180, because there's 180 degrees in 1 pi. Okay, so you get pi over 2. 4 pi over 15, converting degrees, you multiply by 180 over pi. The pi's cancel. 15 goes into 180 12 times, so it should be 48 degrees. Am I right? Okay, I'll assume I am. 7 pi over 6. Look at you in a circle. Should be easy. Okay? Arc length. Arc length is, and this is in degrees, so x over 360 times 2 pi r. So 30 over 360 times 2 times pi times 5. So it's 1/12 times 10 pi, which is 5 pi over 6. Woo. Got to round it to 3 decimal places. 5 times pi divided by 6. You're really focusing. 5 pi over 6, what is it? 2.618. Okay, find the exact area. Area equals, and then this is in radians, so we have to use the radians formula for sector area, which is, oh, did that get erased? That did get erased, didn't it? So the area equals, should be the angle r squared, or r over, I forget off the top of my head. I know there's a square in there. Divided by 2. Is that it? Something's over 2. I think it's 8r squared. It's the angle times r squared over 2. Pretty sure it is. So if we try that, we get the angle pi over 3 times 12 squared divided by 2. Okay? So it's pi over 3 times 144 divided by 2. 144 over 2 is 72. 72 over 3 is 24. So it should be 24 pi. All right. Minutes cancel with minutes, radians with radians, revolutions per hour. So it's 13 times 60 divided by 2, press equals, divided by pi, press equals. Don't divide it by 2 pi, because if you divide by 2 pi, the calculator will think you're dividing by 2 and then multiplying by pi. You have to divide by 2 and then divide by pi as well. Okay? So we know it's revolutions per hour. How many revolutions per hour would this be? 13 times 60 divided by 2, press equals, divided by pi, press equals. What do we get? 124.1. A windmill generating electricity has a blade 50 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity when the windmill is rotating this many revolutions per day. So we say 34,877 revolutions per day times there's 2 pi radians per 1 revolution times, okay, we want to get radians per second. So I know that there are, in one day, there's 24 hours. And then in 1 hour, there's 60 minutes. And then in 1 minute, there's 60 seconds. So you take this 34,877 times 2 times pi divided by 24, press equals, divided by 60, press equals, divided by 60 again, press equals. How many radians per second is that about? 2.5? I don't know. I'll go with it. Okay, saw blade. 3350 times, that's revolutions per minute. Should put on the label so I know what to cancel. Revolutions per minute, and I got to get to miles per hour. So I know there's 2 pi radians in 1 revolution times 15-inch diameter blade makes it 7.5 inches per radius, which cancels with radians. So I have inches per minute, and I need miles per hour. So times 1 foot is 12 inches, and then 1 mile is 5,280 feet. So revolutions, radians, inches, feet, miles per minute. So now I got to get to hours. So in there's 60 minutes, there's 1 hour, and minutes cancel with minutes. So 3350 times 2 times pi times 7.5 times 60 divided by 12 divided by 5280. And you should get the number of miles per hour. Now this one's screaming along, I bet over 100 miles an hour. what do we get? 149.5 miles per hour. Okay. All right. So I have a coordinate at -7, 7. -7, -7. What's 7 squared plus 7 squared? 49 plus 49 is 98. So if we take the square root of 98, the square root of 49, square root of 2, which is 7 square root of 2. So that's what our hypotenuse is. So to find the sine, it's opposite over hypotenuse, which is -7 over 7 square root of 2. The 7's cancel, multiply top and bottom by square root of 2. So it's negative square root of 2 over 2. Cosine, same thing. Negative square root of 2 over 2. Because you start out with -7 over 7 square root of 2. Tangent, -7 divided by -7 is +1. Cosecant is 7 square root of 2 over -7. The 7's cancel, so you get negative square root of 2. Secant is the same thing. So it's negative square root of 2. Cotangent is +1 because of adjacent over hypotenuse. Find the exact value of cosine of 4 pi over 3. You just look on your unit circle and you get -1/2. Exact value of tangent at that point. Well, -5 pi over 6 is right there. Okay. Where cosine is negative square root of 3 over 2 and sine is -1/2. So it's -1/2 over negative square root of 3 over 2. Multiply both the top and bottom by 2. So you get -1 over negative square root of 3. Multiply top and bottom by negative square root of 3. And you get square root of 3 over 3, which is choice C. Cosine of -120. -120 is about right there. Cosine is -1/2. Cosine of 0 degrees, inverse cosine of 0 degrees. Where's cosine 0 at? Where's cosine 0 at? 90 degrees. Where is the sine 1 at? Also 90 degrees.
I'm sorry. This is,
Yeah.
I have a question. So I'm reading, they're due on the 14th.
But that's wrong.
Okay.
We got emails about that.
It says the 15th.
Yeah.
By noon tomorrow.
By noon tomorrow.
Okay. So what else? Is the start time wrong too?
No.
Everyone's asking me about.
Well, because it was on our calendar as a 2:30 start time for field events, and it's an 11 o'clock start time for field events because they didn't have school scheduled, so they just moved the meet way up. So
okay, so we're gonna leave at.
We're leaving at 9.
We'll get there at 10. Okay, because the middle school has a problem with that.
Yeah, I know.
I know.
I've already gotten
I
2 phone calls.
I said call Ellen. 9 o'clock leave time.
Leave time 9 o'clock.
That's everyone.
Everybody's going on one bus.
Right. Thank you so much. Thank you. All right. I think I got it now.
Okay, 19. You type this into your calculator. So you go inverse sine of 0.3174. How many degrees is that to the nearest tenth? 18.5 degrees. Okay? Are we good with that? Okay, make sure your calculator is in degree mode, not radian mode. So know the mode of your calculator. Jenny's having power nap over there. All right. So on this one, we got to figure out what this side is. So 41 squared equals 9 squared plus a squared. So 41 squared is like 8. Oh, no, it's
1,681.
Yeah. 1,681 equals 81 plus a squared. Subtract 1,600 equals a squared. So a equals 40. So the sine of A is opposite over hypotenuse, which is 40 over 41. The cosine of A is 9 over 41. The tangent of A is 40 over 9. Then we move to angle B. The sine is 9 over 41. The cosine is adjacent over hypotenuse, 40 over 41. And the tangent is opposite over adjacent, 9 over 40. Okay? Half done. Solve the right triangle. Now we start to get to ones where we have to do a little more math. Okay? 16 degrees here. C is 29. Got to use your calculator. To figure out angle B, angle beta, we take 90 plus 16, which is 106. So this is 74. So this is alpha, this is A, this is B. So figure out A, it's a sine of 16 equals A over 29. And the cosine of 16 equals B over 29. And that's how you figure out A and B. What do we get for A? What do we get for B? A should be somewhere around 10, I would guess, or even smaller. What did you get, Candy? Did you go 29 times the sine of 16?
What do you want it in?
To the nearest 10th. 8.0. Okay? So 8.0 for A. And then to get B alone, multiply by 29. So it's 29 times cosine of 16. 27.9. Okay. Cosine of 7 pi over 6 is negative square root of 3 over 2. Sine of negative 330, again, look on your unit circle. It should be 1/2. No, sine of negative 330. We're going this way around 330 degrees, so we're really at 30 degrees. So it's positive 1/2. All right. Then, that was all chapter 1. The first 23 questions were chapter 1. Okay? Then we have just a couple over chapter 2. Now, if we would have done chapter 2 on Math Excel, we would have had things like this, and you want to learn hardly a thing. That's why we graphed them out. Okay? The amplitude is the difference from the highest to the lowest divided by 2. Okay? Well, each of these, the difference between the highest and lowest is 2. Divided by 2 is 1. Okay? The phase shift, how far does it shift right or left? This shifts left pi over 2. So it's a negative pi over 2 that it shifts. It shifts left pi over 2, so you're going to negative pi over 2. Which is the correct graph? Well, cosine starts up here and crosses that pi over 2 and whatever. So if we shift left pi over 2, this point is here, this point is here. It should go down through there, which is choice C. Okay, the other one from that chapter. Cosine of 4x. So the period is 2 pi divided by b. And b is 4 here. So it's 2 pi divided by 4, which is pi over 2. That's the period, pi over 2. The phase shift. There is no phase shift because we're not shifting left and right. We're shifting 2 up. Okay? So phase shift is none or 0. I think it's 0 is what we should go with. The range Well, if we're shifting everything up by 2, we start at -1 and normally go to 1. If we shift everything up by 2, we start at 1 and go to 3. So it's from 1 to 3, and it's a cosine really skinny, which is this one right here. I add, because normally cosine goes from -1 to 1. So if we go up by 2, it goes from 1 to 3. The normal cosine curve starts at 1, goes to 0, goes to -1, goes to 0, goes to 1. Okay? So if we shift everything up by 2, it starts at 1 and goes to 3. $26. How many degrees are left for y? 61 and 75 make 136, right? What's 180 minus 136? 44. Okay, and now we have to use law of sines to figure out b and c. So the sine of 61 over b equals the sine of 75 over 14.1. We cross multiply and solve. So 14.1 times the sine of 61, press equals, divided by the sine of 75, press equals, and then we get our answer. I'll go with 12.8. I have no clue, so I'll trust it. And then the last one, sine of our angle 44 over c equals the sine of 75 over 14.1. So c is going to be smaller than b. So it's going to be smaller than 12.8. $10.1. All right, solve the triangle with the given parts. This is a side, side, side. So 21.6, 14.8, 15.1. So the law of cosines. If we want to find a first, then it's a squared equals b squared plus c squared minus 2bc cosine of alpha. So 21.6 squared equals 14.8 squared plus 15.1 squared minus 2 times 14.8 times 15.1 cosine of alpha. So looking at this, I can take 21.6 squared minus 14.8 squared minus 15.1 squared, and I get 19.51 equals, then I take 2 times 14.8 times 15.1, that's 446.96, and it's negative cosine of alpha. So if we divide by negative 446.96, I get that number. And if I go second cosine of my answer, inverse cosine of my answer, whoop, I got to be in the other mode. I got to be in degree mode. Mode. Oops. What did we get for an answer? Did anybody do this? Okay. Inverse cosine of 19.51 divided by negative 446.96. Inverse cosine. Mr. Bierschbach is really struggling. 19.51 divided by negative 446.96. Boom. 92.5 degrees. Woo, finally. So this is 92.5 degrees. So we could use law of sines to figure out B, beta. So the sine of beta over 14.8 equals the sine of 92.5 over 21.6. Cross multiply and solve, and then just subtract, find the other angle. Okay? We have two law of cosines problems. Yes, Jenny? No? Because they're doing testing right now. Oh.
Did you see the email? It just said that Carson Schneider didn't even start until 20 minutes ago. So you don't have to take it. So you can take it after you or in a They've been sitting there for 2 hours trying to figure out how to start this test.
Nice.
I don't want to give me my money back. I'm so sick of it.
Okay. So let's say we want to figure out B. Then B squared equals A squared plus C squared minus 2 AC cosine of 97.2. So you just put it into your calculator. So this goes straight into your calculator. It's a lot easier. 8 squared plus 12 squared minus 2 times 8 times 12 cosine of 97.2. You get what B squared would be. So then you take the square root of your answer and you get 15.23. Now you know that had to be bigger than 12 because this is an obtuse angle. Okay? So it has to be bigger than the remaining biggest side. Then you do law of sines to figure out the other two. So you go sine of 97.2 over 15.23 equals sine of alpha over 8. Cross multiply, solve, and figure the other ones out. Good enough. Okay, Heron's formula. Heron's formula is A plus B plus C all divided by 2 to get S. 9 plus 15 is 24 plus 14 is 38. Divide by 2, which is 19. So you take the square root of 19 times 19 minus 14 times 19 minus 9 times 19 minus 15, or the square root of 19 times 5 times 10 times 4. That's 200. So that's the square root of 3,800, right? Yep. So square root of 3,800 is 61.64. Find the area of this with side angle side. So it's 1/2 of 8 times 6 times the sine of 63 degrees. 1/2 of 8 times 6 times the sine of 63, which is 21.4, 21.38, because it says round to the nearest hundredth. So make sure you look at the directions when you're taking this. A for this one is at 1, 4. B is at 5, 1. If we add them together, it'd be 6, 5. A minus B is at negative 4, 3. So we find the one that's 6, 5, which is this one. Find the one that's negative 4, 3, which is this one. The magnitude and angle of the vector. The magnitude is the square root of 1 squared plus 3 squared, which is the square root of 1 plus 9, which is the square root of 10. The angle, we're in quadrant 1. So the angle is just what you get when you take the inverse tangent of 3 over 1. The inverse tangent of 3 over 1 is 71.6 degrees. Now, if any of these were negative, you got to go into a different quadrant, but you only use positive numbers here. And then you subtract from 180 or add from 180 to find the angle, or subtract from 360. You had to know my most favoritist of all time problem, the donkey problem, would be on here. So you draw a parallelogram. If this is 30 degrees, this would be 150 degrees. We draw this across. That's the force that the prospectors are pulling. And if the donkey is staying, it's at an equal and opposite force. This is 50, this is 75, so it's a law of cosines. So it's 50 squared plus 75 squared minus 2 times 50 times 75 cosine of 150, because cosine of the angle opposite. So it's 50 squared plus 75 squared minus 2 times 50 times 75 cosine of 150. And then we take the square root of the answer. So 120.9 pounds of force that donkey is pulling back at. All right, then the last chapter, what's cosecant over cotangent equal to? Well, cosecant is 1 over sine. Cotangent is cosine over sine. So if we multiply both the top and bottom by sine, we get 1 over cosine, and 1 over cosine is secant. Secant times cosine is 1 over cosine times cosine, which is just plain simple 1. We FOIL this, we get sine squared of alpha minus secant squared of alpha, which is choice B. Sine minus cosine over cosine is sine over cosine minus cosine over cosine, which is tangent minus 1. This one's a matching one. It's kind of confusing, but tangent times cosine, cotangent cubed. Tangent we can turn into 1 over cotangent, because you look at the 3 choices, and 1 over cotangent is the only thing that fits there. So 1 over cotangent times cotangent squared, because I split up the cotangent cubed into cotangent and cotangent squared. So these two cancel, and it's 1 plus cotangent squared, which is cosecant squared. All right. So, whoops. So we can use sum and difference on the last two. So the cosine of 19 pi over 12 is the cosine of 9 pi over 12 plus 10 pi over 12, which is the cosine of 3 pi over 4 plus 5 pi over 6, which is cosine of 3 pi over 4 cosine of 5 pi over 6 minus sine of 3 pi over 4 sine of 5 pi over 6, which is square root of 2 over 2, nope, negative square root of 2 over 2, cosine of, so times negative square root of 3 over 2, minus square root of 2 over 2, square root of 1/2. So it's positive square root of 6 over 4 minus the square root of 2 over 4. So it's the square root of 6 minus the square root of 2 all over 4. And the last one, negative 13 pi over 12, is the sine of 3 pi over 12 minus 16 pi over 12. So it's the sine of pi over 4 minus.
Isn't that all the same problem?
What do you mean? I don't know what you mean.
It's the same problem, and you're just supposed to circle your answer.
No, you have to work it out, Ryan. So pi over 4 minus 4 pi over 3. So it's the sine of pi over 4 cosine of 4 pi over 3 minus cosine of pi over 4 sine of 4 pi over 3. So this is square root of 2 over 2 and negative square root of 3 over 2 minus square root of 2 over 2 and negative 1/2. So it's negative square root of 6 over 4 minus a negative square root of 2 over 4, which would go plus positive. So it's negative square root of 6 plus square root of 2 all over 4. Negative square root of 6 plus the square root of 2 all over 4. And that is what you'll see on your test. So we have, now what? We have another 40 minutes for you guys to work on the practice test. So go ahead, work on the practice test today. And then tomorrow, Thursday, when I'm gone,